Hello and welcome to another episode of CSEC Math with Sir Kumar. In today's episode, we're going to look at time and average speed. We're going to define what is time, and then we're going to look at the 12-hour clock plus the 24-hour clock. And then we're going to go and calculate the length of time taken for a journey. So arrival time and departure time. So we're going to calculate time, and then we're going to go and find what is average speed and apply the formula to solve questions with average speed. The first thing we're going to look at is time. So let's just define what is time. Time is the measurement of a period or instant in which something happens in the past, present, or future. As you know, the length of a day is usually 24 hours. And we divide it into two portions. So you have the one that goes from midnight to midday. That's the first 12 hours. And then you have the second 12 hours going from midday to midnight, or we say noon to midnight. So you have that here, the first 12 hours is from midnight to noon, or which we call midday. And the second 12 hours is from noon to midnight. Now, with the 12-hour clock, we know that from midnight to noon or midday, we usually refer to that as AM. And if you look here, AM is anti-meridian, which meridian means before midday. Meridian means midday, so anti is before midday. And then the second half that goes from 12 midday to 12 in the night, it's PM, and that's post-meridian, meaning after midday. You have here a 12-hour clock. Everybody know what a 12-hour clock looks like, because this is the one that we usually see selling all over the place. It starts from 1 and it ends at 12. So let's say we start at 12 midnight. So from 12 midnight going to 12 midday, this is AM. And then from 12 midday going to 12 midnight, this is what we call PM. Now, this is the traditional 12-hour clock, right? This is not the 24-hour one as yet, because most persons still use this. They don't use the 24-hour one as much as the 12 hours. So if you look below here, I have 4 diagrams, simple exercise, to help you to read the time or tell the time. So the shorthand is what we use to tell the hour, and you have the long hand, which is the minute hand. Between each one of these numbers is 5 minutes. So if you check it, you have a total of 60 minutes in an hour. So the first thing we do is we look for our shorthand, and our shorthand here is pointing to 2. So the time is going to be 02. And remember, between each one of these numbers is 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So it's 02, 50, right? Or the local people would say, oh, it's 10 to 3. Because 2:50 is 10 minutes to 3 o'clock. So we say 10 to 3. But if you're going to write it, it's 02, 50. If you look at this one, our shorthand is at 4. So this is 04. And the long hand is at 2, so that's 5, 10. So it's 0, so it's 4, 10, or we would say 10 after 4 for the local people. Here, our shorthand is at 8. So we have 0, 8. And then you have the long hand at 5, that's 5, 10, 15, 20, 25. Or we would say 25 after 8. And then this one, you have the shorthand at 12 and the long hand at 6. That's 5, 10, 15, 20, 25, 30. And we would say 12:30. Now, depends on the time of the day. If it's 2:50 in the morning, this is like just after midnight, it's going to be 2:50 a.m. If it's 4:10 in the afternoon, then it's going to be 4:10 p.m. Remember that the earlier part of the day, that's going from 12 midnight to 12 midday, it's a.m. And from 12 midday to 12 midnight again, it's PM. We're now going to look at the 24-hour clock and how we write the time using the 24-hour clock. So we looked at the 12-hour clock. Now let's look at the 24-hour clock. So the 24-hour clock starts from midnight, and that is 00 hours. And you have two parts again. It goes from 00 hours, which is 12 midnight, to 12 midday. And once you're reading time that goes from midnight to midday, we use numbers from 1 to 12. And then the second half goes from 1200 hours to 12 midnight. And for those times, that would be like from 12 midday going on to midnight. We use numbers from 12 to 24. If you look here, we have the 24-hour clock. So at 12 midnight, it's at 00, and then you start from 0, 1, 2, 3, 4, 5, 6, 7, and you go to 12. But when you reach 12, this is 12 midday, you start going in the afternoon to 13, 14, 15, 16, 17, all the way to 2400. So 12 serves as the starting of the day, which is 00, and also the ending, which is 24. Now, I have 4 examples here, or 4 clocks. Let's try and write the time. So the first two, we're looking at time between 00, 100 hours, to 1200 hours. That is from midnight to midday. So the first one, since we're dealing from midnight to midday, we have to use numbers from 1 to 12. So our longhand is at 3. So this is going to be 03, and the shorthand is at 8. So that's 5, 10, 15, 20, 25, 30, 35, 40. So this is 03, 40 hours, and this is 3:40 in the morning. Let's look at this one. Again, we're still in the first half of the day. So our shorthand is at 10, and the longhand is at 1. So this is going to be 10:05 hours. So from midnight to midday, we use numbers from 1 to 12. Let's look at these two, which goes from 12 to 2400 hours. This is 12 midday to midnight. So the first one we have, our shorthand is at 2, sorry. So since we're going in the afternoon and we have to use numbers from 12 to 24, we now write this as being 14 for the hour, and the minutes is going to be 5, 10, 15, 20, 25, 30. So this is 14:30 hours. And this one, our shorthand is at 8, so it's in the night. So this is going to be 20, and the longhand is at 4, 5, 10, 15, 20. So this is going to be 20 hours. So what you must remember is that when you're dealing with the first half of the day, midnight to midday, you use numbers from 1 to 12. And when you're dealing with time from midday to midnight, we use numbers from 12 to 24. Here we have some general points that you should know. 60 seconds equals 1 minute. 60 minutes equal 1 hour. And 24 hours equal 1 day. So now you know how to use both the 12-hour and the 24-hour clock. We're now going to calculate time. Now the formula is the difference in time is equal to the time of actual arrival minus the time of actual departure. So here you have some examples. Calculate the length of time for each of the following journey. You have the time of departure given, and then you have the time of arrival given. So let's work these out to find the length of the journey. So the first one, we have the time of departure. So we say departure is equals to 03:39, and this is AM, and the arrival is equals to 06:43, a.m. So if we look at our formula, it's the actual time of arrival, subtract the actual time of departure. So setting this down, we put our arrival time first, and that's going to be 06:43, and the departure is 03:39, and we minus. So when you look here, you have 43 and then you have 39. So if you take 39 from 43, you're going to get 0, 4, and 3 from 6 is going to give me 3. 0 from 0 is 0. But this is not like 0, 3, or 4. This is actually 3 hours and 4 minutes. Therefore, therefore the length of the time for the journey is 3 hours and 4 minutes. Let's look at the second one. So you have departure is 07:38 a.m. Number 2, departure is 07:38 a.m. and arrival is 11:18 a.m. Now arrival subtract departure. So the arrival is 11:18 and the departure is 07:38, and we have to subtract them. Now if you notice here, you have 18 and then you have 38. So we cannot take 38 from 18. So we take an hour from here. So if we take an hour from here, this becomes 10. And if we're taking 1 hour, therefore we're taking 60 minutes. So when we take the 1 hour across here, it would be 60 minutes plus our 18 minutes, and that's going to give me 78 minutes. Remember, I'm taking 1 hour, which is equivalent to 60 minutes. And if I take it across to the minute side, it's going to be 60 minutes plus the 18 that I already have, make it 78. So 8 from 8 is 0, 3 from 7 is 4, and then you have 7 from 10 is going to give me 3. So this is 3 hours and 40 minutes. Therefore, the length of time for the journey is 3 hours and 40 minutes. Our third example, so you have the departure time is 1:15 p.m. So departure is equals to 1:15 p.m. and the arrival time is 03:12 p.m. Now, since these are in the afternoon, then we're going to write them as 24 hours. So 1:15, remember after 12 it's going to be 15 hours, and 3:12 is going to be 12 hours, right? Formula is arrival subtract departure. So our arrival time is 15:12 subtract our departure, which is 13:15. So again, we have 12 minutes here and then we have 15 minutes here. We cannot take 15 from 12. So we take an hour from here. This is going to become 14 So if I take an hour, I'm taking across 60 minutes. So 60 minutes plus 12 is going to give me 72 minutes. And 15 from 72 is going to give me 57 minutes. And 13 from 14 is going to give me 1. So the time here is 1 hour and 57 minutes. So we write it, therefore, the length of time for the journey of is 1 hour and 57 minutes. Let's look at number 4. So number 4, we have our departure as 10:45 a.m. and our arrival as 07:32 p.m. So departure is equals to 10:45 a.m. and arrival is equals to 07:32. Now, the departure is in the morning, or arrival is in the night. So for this one, we have to change our 7:32 into 24 hours, and 7:32 is going to be 19:32 hours. Formula is arrival subtract departure. So our arrival is 19:32 subtract our departure, which is 10:45. Again, we cannot take 45 from 32. So we take 1 hour from here, this becomes 18. We take 60 minutes plus 32 is going to give me 92 minutes. 45 from 92 is going to give me 47 minutes, and 10 from 18 is going to give me 8 hours. So writing this out, we say, therefore, the length of time of the journey is 8 hours and 47 minutes. And our final example, the departure time is 09:12 p.m. and the arrival time is 06:45 the next day. That means this person is leaving at 9:12 in the night and arriving at their destination at 6:45 in the morning. So departure. So the departure is equals to 09:12 p.m. and the arrival is 06:45. So since the departure is in p.m., we convert this to 24 hours, and this is going to give me 21:12 hours. Now, for this question, remember I said that we split the time into two 12 hours. So what we're going to do is we're going to find the time from 21:12 hours to 12 midnight, which is 100 hours. So let's do that part first. So for the first part, we're going to have 2400 hours minus 21:12, And here, 12, we cannot take 12 from 0, so this becomes 23, and this becomes 60 because I'm taking 1 hour across. So 12 from 60 is going to give me 48 minutes, and 21 from 23 is going to give me 2 hours. Now, from 21:12 p.m. to 2400 hours, which is 12 midnight, the person took 2 hours and 48 minutes. And remember, they're arriving at 6:45 the next day. So from 12 midnight to 6:45 the next day is going to be 6 hours and 45 minutes. So we know that, right? So the final part is going to be this 2 hours 48 minutes that it took from 9:12 to midnight. They took 2 hours 48 minutes, plus from midnight to 6:45 it's 6 hours and 45 minutes. And we add the 2 to find the total time taken, right? So 48 plus 45 is going to give me a total of 93 minutes. Remember that there are 60 minutes in an hour, so we cannot put 93 here, right? Because this would give me 1 hour and 33 minutes. So I'm going to put in the 33 minutes here, and then the 1 hour, I have to add the 1 hour up here. So for the hour, we're going to have 6 and 2, 8 and 1. That's going to give me 9 hours. The length of time for the journey is 9 hours and 33 minutes. Now, for some persons, just looking at this, or looking at all the examples as a matter of fact, they could just say, okay, it's 9:12, and then they start to calculate mentally how to do it. That's fine, but if you want to do the working, the 5 examples are the method of how you use the formula, which is the actual time of arrival subtract the actual time of departure. The next part of our lesson is based on speed. So a definition: the speed of a body is defined as its rate of change of distance with time. That is, speed is the quotient of distance divided by time. And you have here average speed is equal to the distance traveled divided by the time taken. Now let's look at this formula a little. We have average speed. Now let's say you take a bus from Georgetown and you're heading up to the University of Guyana. The bus wouldn't go at one pace all the time. So at some part it would go fast, and then it would go slow, and depends on traffic and so on. So that's why we say average speed. So it's not a constant speed, but it's the ratio between the distance covered and the time taken. So that's why we say it's the average speed. So looking at the formula, we take out what is important. So in order to find average speed, the formula is S is equals to distance over time, where S is the average speed, D is the distance, and T is the time. Now, in some examples, you would be asked to calculate the average speed, which you're going to use this formula. And in some, they would ask you to find the distance, or some they would ask you to find the time. So let's transpose this formula to make D, which is distance, the subject, and to make T, which is time, the subject. So let's do that here. So for distance, you remember the formula is speed is equals to distance over time. So how you have s alone on one side, we want to change this formula so that d alone is on one side. The operation here is division. So since I want d alone on this one side, therefore I have to move time. And the only way I could move time is by multiplication. So I multiply here by t, and I do the same on this one side. T and t would cancel out each other. So what I have is d is equals to the speed, the average speed times the time. So this is the formula we use to find the distance. And for speed, again, we use back our general formula, which is s is equals to distance over, sorry, this should be time. For time, that means now we want t alone on one side. So in order to move t, we multiply again by t, and we multiply here by t. So we end up back with st is equals to d. But I don't want st, I want t alone. So the operation here is multiplication. In order to move the s, we have to divide it out. So we divide by s and we divide by s. This and this goes. So t is equals to distance divided by average speed. And this is the formula we use to find time. So you don't have to remember the whole transposition process. All you have to remember is the distance formula, the time formula, and our average speed formula. So now we're going to go to some examples where we're going to use these formula to calculate the average speed, the distance, and the time. So let's look at some examples. The first one, a bullet takes 3 seconds to travel a distance of 1200 meters. Calculate the average speed of the bullet. Remember, our formula carries 3 parts. That is speed, distance, and time. So after reading this, let's see what's given. So a bullet takes 3 seconds. That would be our time. To travel a distance of 1200 meters, that's going to be our distance, right? And they're asking you to calculate the average speed. So we don't know the speed. So the formula that we're going to use is average speed is equals to distance over time. S is equals to the distance, which is 1200 meters divided by the time, which is 3 seconds. Speed is 1200 divided by 3 is going to give me 400 meters per second. And this is the average speed of the bullet. The second example, a TriStar jet travels for 6 hours at an average speed of 650 kilometers per hour. What is the distance covered in that period? Again, 3 parts to the formula: speed, distance, and time. So what is given? A TriStar jet travels for 6 hours. That is the time at an average speed of 650 kilometers per hour. So in this one, they give us the average speed, and they want us to find the distance. So we don't know the distance. So the formula we're going to use here is d is equals to average speed times time. The distance is equals to our average speed, which is 650 kilometer per hour, multiplied by the time, which is 6 hours. The distance covered in the slash means that it's km over h. So the h is going to cancel out each other. So 650 multiplied by 6 is going to give me 3,900 kilometers. So the distance traveled, or the distance covered by the jet for the 6 hours is 3,900 kilometers. And our third example, what amount of time will a car take to travel 84 kilometers at an average speed of 48 km per hour. Again, our three parts: speed, distance, and time. What is given? What amount of time will a car take to travel 84 km? 84 km becomes our distance at an average speed of 48 kilometers per hour. So our average speed is 48 kilometers per hour. They want us to find time. And the formula for time is equals to distance over speed. Time is equals to the distance covered, which is 84 km divided by the average speed, and the average speed is 48 kilometers per hour. Km and 8 km would cancel out each other. The time is equals to 84 divided by 48, and that's going to give me 1.75 hours. And this is how you calculate the time. So if you look back at our example, this one is speed, which is S, is distance over time. This one is distance, which is D is equals to speed times time. And this one is time, which is distance divided by speed. So there you have the application of all three of the formula in speed, in calculating average speed. To sum up today's lesson, we looked at time and average speed. And on the time, we focused on the 12-hour clock and the 24-hour clock. And we looked at how we represent the time, or how we write the time in both scenarios. Then we also calculate length of time for a journey. And that is the time of arrival take the time of departure. Then we looked at average speed. Remember, average speed is the distance divided by the time. The distance covered divided by the time taken. And there's one formula, which is S is equals to D over T. And then you could transpose that formula to find the distance and to find the time. Just remember the three formula and when you have to use them to solve questions given.